Well, hello everybody. Uh, in this video, I'm going to talk about twin primes a little bit. In 2008, I found a relationship between twin primes and multiples of six that I found a little surprising because it is highly approachable, but not very popular. I would have thought it would have been a sort of a trivial note that would be mentioned when in articles about twin primes, but it wasn't. I suspect that most mathematicians would probably find it too trivial to be noteworthy, but I don't know. It amused me anyway. So I made a video many years later, just a few years ago, and in that video I made a claim, but I neglected to clarify why the claim was true. So I guess it's better late than never to do that here today. So what do we do here? We start out by laying out some multiples of 6 and the numbers leading up to those multiples of 6. So each one will be a sort of a batch of 6 numbers with the multiple of 6 at the top. Here we can see the first row, multiples of 6, which of course are multiples of 2 and 3, because 2 times 3 is 6, believe it or not. And then we have another row after that, which I've added a thinking face for. And then the next row there is always going to be multiples of 2 in those slots. And the next row after that, will always be multiples of 3. And then again, multiples of 2 in the next row. And then I've added another thinking face for the final row. What can we do here? Well, just as a sort of a convention, I'd like to sort of slide up or shift that window that we're looking at up by 1, just so that the multiples of 6 are in the second row from the top instead of the bottom one. So let's take a look at the next one here. Now we've got the multiples of 6. It's all the same numbers there, except for we've dropped 1 and we've added 31. But everything else has shifted around, but remains intact. There are 2 thinking face rows, and then there's the multiple of 6 itself, and then the multiples of 2, 3, and 2. All right, so that's pretty clear. We'll drop the bottom 3 rows as sort of uninteresting. Multiples of 2 and 3 are very frequent, and we know where they are, so I'm not going to focus on those. I'm going to drop them. So here in section number 3, I've done just that. And for the thinking face rows, I've tried to add some kind of detail that might be useful to us. And that detail is that we know that the multiples of 6 are 6 times m for some factor that it's a multiple of. And then the row above is going to be 6m plus 1, and the row beneath is going to be 6m minus 1. I think everybody can grasp that pretty easily. So let's give some names to these things. All right, let's call the 6m plus 1, we'll call them a high number, a high position, or an H. And the 6m minus 1, we'll call that low, or L. All right, moving along here. Is there anything interesting to be said about these? Well, one thing we could ponder is, well, what happens if you multiply a low times a low? What happens if you multiply a high times a high? What happens if you multiply a low times a high? Does anything special happen for any of these cases? Well, let's take the first case here. A low times a low. Well, all right, the definition of a low is 6m minus 1. Okay, so let's make a number that's a low. We'll call it 6x minus 1. And another low could be 6y minus 1. X and y just need to be non-zero positive integers, and they could even be the same number, but we're using x and y just to distinguish them for the moment. And so what happens if we multiply this out? All right, 6x times 6y, well, that's 36xy. And how about 6x times minus 1? Well, that's minus 6x. Moving along, minus 1 times 6y is minus 6y. And then minus 1 times minus 1 is plus 1. So we've got that as a row in section number 6. And what can we do? Well, we can factor out a 6 from some of those numbers. So I've done just that. We've got 6, and then in brackets we've got 6xy minus x minus y. And then all of that plus 1. And what does that give us? Well, that looks familiar. The form of 6 times something plus 1, well, that's just the definition of an h, a high number. So what we find is when we multiply two lows, we get a high. Well, how about the next situation? High times high, what do we get? Well, for high times high, we have 6x plus 1, because it's above a multiple of 6, and 6y plus 1, that's another one that's above a multiple of 6. And we do the same sort of thing here. We get 36xy plus 6x plus 6y plus 1. We factor out the 6, we get 6 by 6xy plus x plus y, all of that plus 1. And that gives us a high as well. So now we've got low by low gives us a high, and high by high gives us a high. What about the final combination, low times high? Low times high here. Okay, so for a low number, we will have 6x minus 1, because it's below a multiple of 6. And then the high number will be 6y plus 1. And if we work through that, pardon me, if we work through that, we eventually get a 6 times 6xy plus x minus y, all of that minus 1. Well, the form of that is 6 times some number minus 1, so that's a low. So when we multiply low by high, we get a low. All right, that's interesting. Okay, well, that's our summary here in section number 9. How about thinking more about it here? All right, so low numbers can be primes, or I hope you're able to trivially convince yourself that any prime beyond 3 has to be in one of those two slots, low or high, because all the rest of the numbers are divisible by 2 or 3. So what have we got? Lows can be either primes, or we just established they could be the result of a low times a high, or maybe something else. We know that we can, every low times a high will give us a low, but we don't know if we're covering all the ground of lows just yet. So that's an open question for a moment. And with highs, they can be primes, or they could be the result of a low times a low, or a high times a high, or maybe something else. Well, what can we say about any of that there? If we have a low and we're claiming that it is not a prime, but it's a composite number, or composite, whichever you prefer, then what can we say about what its composition will be? Well, we know that it's 6m minus 1 by definition, so it can't have 2 or 3 as factors, because if you move one position away from a multiple of 6, you can't land on a multiple of 2 or a multiple of 3. And similarly, for a high number, it's 6m plus 1. You move one slot away, you can't have 2 or 3 as factors. So these are all going to have these composite numbers are all going to have factors that are either primes, that are L and H primes, or powers of primes. So let's consider exponents for a moment here. Here we have C. C is a composite number, and the usual form of a composite number is that it'll have at least one prime, and that prime will be raised to a power. That power might be just 1. So the form I've written here is the first prime to the power of some first power times a second prime to the power of some second power, and so on, eventually to some nth prime raised to some nth power. Well, what do we what can we do about an example here? One example might be 5 to the power of 9 times 13 to the power of 2. Well, those primes are 5 is a low and 13 is a high, so I've typed that in here. And if we expand all that out, we've got 9 lows, low factors, low by low by low, by low by low by low, by low by low by low, and then we've got 2 H's, by high. And then I've expanded it out here because we know that a low by low gives us a high. So we've got 1, 2, 3, 4 of those highs. And then we've got a stray low, seemingly, after that. Then we've got a couple of highs. Well, we know that a high by high gives us a high, so I've reduced that into a high there. And then on the next line, we've got another pair of highs that gives us a high, another pair of highs that gives us a high, and then the previous stray low times the high, well, that gives us a low. In the next line, we've got 2 highs, that gives us a high, and we'll carry the low down, and then we finally multiply the high by the low, and we end up with a low. So after going through all of that, we realized that it doesn't really matter what the exponents are. All of this is still going to lead us to either an L or an H. So that means that every composite number that's in an L and an H position must be expressible as the product of L's and H's. Okay, so how about section 13? Section 13, we've got a little bit of a summary here. So a low number can be either a prime or it can be of the form that we established earlier, 6 times 6xy plus x minus y, all of that minus 1. But, x and y are just sort of arbitrary non-zero positive integers, so we can actually get the same thing by switching around the plus and minus signs inside there. There's no reason that they have to be in that order, something strange like that. So on the next line there, I've said, or we can have a low number is the result of either a prime or 6 times 6xy minus x plus y, all of that minus 1. So there's a second form that's equivalent, roughly speaking, to the first one. And then we've got the 2 possible highs. High can be either prime or it can be 6 times 6xy minus x minus y, all of that plus 1. Or it can be a prime or 6 times 6xy plus x plus y, all of that plus 1. All right. Well, okay. That's nice. How about section 14 here? In section 14, I'm revisiting the original, the view, the window in which we have the multiple of 6 second from the top as the second row from the top. And down the last 3 rows, I've got a multiple of 2, a multiple of 3, a multiple of 2. We're not really interested in those. Those are just going to sit there. So what can we say about twin primes? Well, twin primes only appear around multiples of 6. So here I've got a high twin prime as the top row. And we know that in order for it to be a prime number, it can't be a composite number. So then, since we know what composite numbers, what forms that they can take with H's and L's, highs and lows, I've said that this high twin prime cannot be a result of the 6 by 6xy minus x minus y, all of that plus 1. And it cannot be the result of a 6 times 6xy plus x plus y, all of that plus 1. It can't be one of those forms in order for it to be prime. So that's important. Then we've got our multiple of 6, which is 6m. Okay. And then we've got the low twin prime. Well, I'm not going to bore you with reading it all out, but you can see the format for this one is plus and minus with the minus 1, and then it's it could also be minus plus with the plus 1, or with the minus 1. All right, well, is there anything that these can tell us about m, the multiple of 6? In order for us to have twin primes, can we say something about m? Well, yes, I guess we can. What we can say is that for the multiple of 6, that is 6m, we know something about m based on what's around it. M cannot be any of those forms, either the 2 for the high twin prime, and it cannot be the 2 forms for the low twin prime. It can't be any of those 4 sort of forms. Well, we can reduce that a little bit further, and we can just use a plus or minus sign to say m cannot be equal to the form 6 times 6xy plus or minus x plus or minus y. That's the end result, and that's the primary feature of that previous video that I'd made a few years ago. So I hope that helps to clarify, and I hope that you'll find that interesting, even if it is pretty trivial. It's I don't see a lot of discussion about it. It's something you can just amuse yourself with. Well, have a pleasant day, everybody. Take care.